In this video, I will discuss about quantization. So what does quantization means? The digitization of analog signals involves the rounding off of the values which are approximately equal to the analog values. The method of sampling chooses a few points on the analog signal, and then these points are joined to round off the value to a near stabilized value. Such a process is called quantization. So now I will discuss the process of quantization very briefly by a block diagram. So quantization is the process which is required to convert the analog signal into a digital signal. So in this block diagram, we have provided a analog signal, and by sampling the analog signal, we have got the discrete signal. In the analog signal, the time is continuous and the amplitude is also continuous. So after sampling the analog signal, we will get the discrete signal. So what does sampling means? Sampling is defined as the process of measuring the instantaneous value of the continuous time signal in a discrete form, or it is the discretization of an analog signal. So here, after sampling, we have got a discrete signal. In this discrete signal, the time is discrete, but the amplitude is still continuous. So the quantization process converts a continuous amplitude into a discrete form, because to store the discrete signal into a digital system, we need to map the magnitude of the amplitude with a fixed value. So as we can see that after the quantization of a discrete signal, we will get a digital signal, and after the digital signal, we will do coding. Then after coding, we will get a digital data. So now I will discuss about quantization, because as we have mentioned that this video is on quantization. So on the next slide, we will discuss how the process of quantization is carried out. Here we have taken an analog signal which is in red color. So after sampling of the analog signal, we have got the discrete signal. So these are the samples. So by sampling, we have got the discrete signals. So now to store the discrete signal into a digital system, we need to convert the amplitude of a discrete signal which is continuous into a discrete form. So here we have taken each samples of 2 bits, means we can take another bit also, but in our case we have taken 2 bit, means each sample is of 2 bits. So now we will discuss how the quantization level are defined. So here each sample is of 2 bit, so we can define it by taking 2 to the power n. N means the number of bit which we have chosen for each sample. So 2 to the power 2 will be 4, so L. So the blue lines are the quantized level that we have taken. Now there is delta. Delta is the step size, means the amplitude interval. What is the amplitude interval is defined by the delta. Delta is the step size. So the delta can be taken as x max minus x mean by L. So x max is 1 and our x mean is minus 1 divided by L. L we have got 4, so 1 minus 1 divided by 4 it will be 2 by 4, so it will be 0.5. So see here we have taken the blue lines are the quantization level here. So we have taken the step size as 0.5. Here the amplitude interval between each quantization level is 0.5, as we can see here is 0.5. So now we will see that how the quantized amplitude is taken. So we need to take the nearest quantization level for each magnitude of the samples. See, here are the samples. So we have to take the nearest quantization level for each samples. Here the magnitude is 0. For 0, the quantization level will be 0. For 0.5, the quantization level will be 0.5, as we have taken there. For 1, the nearest quantization level will be also 0.5, and again for 0, the quantization level is again 0. For 1, we have taken 0.5 because see here we have taken only 4 quantization level. So we have taken only 4 quantization level, and we can and give it name as 0, 0, 0, 1, 1, 0, 1, 1. We have taken that. So for 1 also the quantization level will be 0.5. So for the amplitude it will be 0.6 or something. The nearest quantization level will be minus 0.5. And for minus 1, do you see here the sample is, the magnitude is minus 1. So for minus 1, the nearest quantization level is minus 1, because here we have taken in minus 1 as our one of the quantization levels. So here it will be minus 1. Here will be the quantization level. So next for the amplitude, the amplitude is minus 0.5. So for minus 0.5, the quantization, the nearest quantization level will be minus 0.5, and for 0 again it will be 0. So by this we can make a table. So in this table we can see that for 0 the quantized value is 0, and for 0.7 the quantized value is 0.5. See, for 7 the quantized value is 0.5. For 1 also the quantized value is 0.5, and for 0.7 also the quantized value is 0.5, and for 0 again it is 0. So like this only for minus 7 we will take minus 0.5, and for minus 1 means that we have seen from that graph. And now for 0 we have taken 1, 0. So for 0 we will take 1, 0. For 0.5 as we have taken 1, 1, and for 0.5 I have a 1, 1, 1, 1, and for 0 again see we have taken 1, 0, and for minus 0.5 we have taken 0, 1, and for minus 1 we have taken 0, 0. So like this we will find a digital signal after the quantization of the discrete signal. So in the next slide we will discuss about types of quantization. So there are 2 types of quantization. Uniform quantization. Uniform quantization means that it is a type of quantization in which the quantization levels are uniformly spaced. Means the quantization levels are uniformly spaced. The step size is same here. Each and every step size is same here. And the second one is non-uniform quantization. In this type of quantization, in which the quantization levels are unequal and mostly the relation between them is logarithmic, is termed as non-uniform quantization. Here the step size are not same, means the quantization levels are not same, they are not uniform. So the next slide is about quantization error. For any system, during its functioning, there is always a difference in the values of its input and output. So the processing, so mainly the quantization error is the difference between the input value and its quantized value. The value which we have given means the difference between in the input which we have given and the output which we have got after quantization of the discrete signal. It is the quantization error. So here we can see the quantization error. See, there are quantizations and the error will be seemed like this. It will be seemed like this. Then the next slide will be quantization noise. It is a type of quantization error which usually occurs in analog audio signal while quantization it to a digital signal. So this is all about quantization. Thank you.